Road to Olympiad.
Welcome to RTO. Consider the following problem. Let A, B, C be positive real numbers such that AB plus BC plus CA is greater than or equal to 3. Prove that A over square root of A plus B plus B over square root of B plus C plus C over square root of C plus A is greater than or equal to 3 over square root of 2. We'll usually use some famous inequality in order to prove some problems involving inequality. But today, we are going to use one uncommon inequality which come out as a lemma in the process of proving. Pause the video if you'd like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, we start by noticing that the given expressions can be written as a square over a square root of a plus b square over b square root of b plus c plus c square over c square root of c plus a by multiplying a, b, and c respectively to each of them on both the numerator and the denominator. Here, we need a lemma. If a, b, x, and y are all positive, then a square over x plus b square over y is greater than or equal to a plus b the whole thing square over x plus y. To prove this lemma is easy. We notice that by multiplying the common denominator xy times x plus y to both sides, we have a square y times x plus y plus b square x times x plus y is greater than or equal to a plus b the whole thing square times xy, which can be expanded and simplified into a square y square plus b square x square is greater than 2abxy. Subtracting the 2abxy, we have ay minus bx the whole thing square is greater than or equal to 0. This is definitely non-negative as a perfect square, so the lemma follows accordingly. With this lemma, we can rewrite the expression just now to be greater than or equal to a plus b plus c the whole thing square over a square root of a plus b square root of b plus c square root of c plus a. Now, notice that a times a plus b times b plus c times c plus a can be written as a squared times a plus b over a plus b squared times b plus c over b plus c squared times c plus a over c, which is also equal to this one. So we can apply the lemma just now again to have it to be greater than or equal to a square root of a plus b square root of b plus c square root of c plus a the whole thing square over a plus b plus c. Multiplying the a plus b plus c to the other side and taking square roots on both sides, we have this one. With this, we now have these expressions which we obtained from the first inequality just now to be greater than or equal to this thing. Here we can simplify the terms with a plus b plus c to get a plus b plus c the whole thing to the power of 3 over 2 on the numerator. Now let's rearrange the information we have so far. We now have a over square root of a plus b over square root of b plus c over square root of c plus a is greater than or equal to a plus b plus c the whole thing to the power of 3 over 2 over the square root of a plus b plus c plus c plus a. So it is sufficient for us to prove that this is greater than or equal to 3 over square root of 2. Cross multiplying the denominators and squaring both sides, we have this one. Notice that the expression on the right can be expanded into this, which can be further written into 9 times a plus b plus c the whole thing square minus 9 times ab plus bc plus ca. Moving them to one side, we have this one. Since it is given that AB plus BC plus CA is greater than or equal to 3, we can have 2 times A plus B plus C the whole thing cubed minus 9 times A plus B plus C the whole thing square plus 27 is greater than or equal to 0. Notice that this may not necessarily be non-negative, but it is still a sufficient condition to show the inequality to be true. To show this, we can simply let A plus B plus C to be equal to x. Then we have 2x cubed minus 9x squared plus 27, which is equal to x minus 3 the whole thing square times 2x plus 3. Since x is positive, as it is the sum of 3 positive real number x, y, z, we have 2x plus 3 is positive, so its product with a perfect square must be non-negative. Therefore, the given inequality in the problem follows accordingly. And this marks the end of our solutions. Post in the comment below if you have any thoughts on the video, and if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.